Dear friends, in this video, I'm present with one more simulator, that is the RC circuit simulator. You can download and use this virtual experiment by the Google Form link given in the description of this video. So I once again welcome you to my YouTube channel with a simulator, and I'm not showing you only the video, but you can download and use this simulator for your own use. So now we go with the simulator here. In this video, I am going to brief you about the RC circuit, and here we go with the theory of RC circuit. A series RC circuit is basically a resistance and capacitance in the series with each other. Whenever a potential is applied, the job of capacitor is stored to charge. So initially the current flows through the circuit, but gradually currents start to diminish as the charge start to accumulate in the capacitor. And as soon the value of charge becomes almost equal to the applied potential, there is no or zero current in this circuit. So RC circuit is a transient kind of circuit. Whenever the DC voltage is applied, here we can see the expression for the charging of the capacitor, and here is the discharging of the capacitor. This is the voltage across the capacitor while it is charging, and at here this is the voltage across capacitor during discharging. And if we apply the AC circuit with the same RC combination, then what happens? The AC circuit polarities are continuously changing, and the job of capacitor is to store the charge. So the AC voltage is continuously changing its instruction of storage of charges to the capacitor in one direction to the other direction. And we are aware that the resistance by the capacitor is less for the high frequency voltages. It happens because it is not capable to store the charge because the polarities are continuously changing, and its resistance as a consequence decreases in the AC circuit. At the same time, the voltage across capacitor in an AC circuit lags behind the voltage across the resistance. So there is a phase difference between the voltage across the capacitor and voltage across the resistance. And hence we can see the expression for the voltages across the resistance and the capacitor. So across the resistance, we have shown it with the cos function, while across the capacitance, we have shown it with a sine function, because at the zero time, the voltage is leading across the resistance while voltage is lagging across the capacitance. So now we will be going to the page of simulator, and we will try to perform the experiment. We will try to observe the various things in a DC circuit with the RC combination and AC circuit with the RC combination. So here there are three tapes. One is the theory tape, which is enabled right now. So color is the green. Another one is the procedure tape. So in this procedure tape, you can see how we can use this simulator. This procedure is completely described here. And the third tape is simulator. As soon we press this, we will be reaching to the simulator. And now we will be going to the simulator and will have a demo of the simulator. So I'm not trying to explain you all the details of RC circuit. Rather, I'm offering you the opportunity to do it yourself and try to understand the underlying concept with the help of the simulator. So my dear friends, please download and use this simulator and provide me with your valuable feedback. So now we are going to the simulator. So you can see here the panel of this simulator. Here is the voltage display, and here there is a power supply, and the power supply there is a switch which is AC. If we press this switch, it will become the DC, and now the display will change. For DC, there are two tapes, the charging and the discharging. At the same time, we have one voltmeter along from the voltage display. This is the sample and hold voltmeter. And in this sample and hold voltmeter, we can take the reading and hold the reading for the particular duration of the time during the experiment. So we can decide for how long we want to retain the reading. So we can change this retention period. So we can have the reading after 2 seconds, we can have the reading after 3 seconds, 4 seconds, 5 seconds, or we can have each and every reading after each second. Now here are two scroll down buttons with the help of which we can increase the value of capacitance. You can see as soon I press up, the value of capacitance is increasing here. If I press down, the value of capacitor is decreasing. Similarly, we can change the value of resistance here. You can see the value of resistance is changing and it is in the kilo ohm, and the value of capacitance in the micro farad. So now with the sample and hold voltmeter retention time of 1 second, we will start our experiment of charging the capacitor, and there may be a little flickering of the screen because of the screen is continuously updating at each iteration of the voltage and time change. So I'm pressing the charging button. Look what happens. As soon the charging button is pressed, the switch is on and the capacitor is gradually charging. Here you can see the gray line is representing the capacitor voltage, while the yellow line is representing the voltage across the resistance, which is gradually decreasing. And the intersection of these two is nothing but the T half in this RC circuit. So you can see the charging graph of this capacitor, the voltage across the capacitor, and here is the voltage across the resistance. So you can change the value of resistance, change the value of capacitor, repeat the experiment, take the observations of the observations are provided here. You can calculate the time constant with the help of graph and as well as with the help of formula. Now we will go for the discharging. So now we will press the discharging button, the same combination. So now discharging, you can see the battery has been eliminated from the circuit and the discharging here has been started. When it comes to the discharging, the voltage across the resistance and capacitor are along the same line. So instead of two lines, you can observe only one line because the nature of voltage during the discharge is same across the resistance and across the capacitor, because if we look at the circuit carefully, two are in the parallel, so voltage across both is same. Now if I press this button and if we push and go to the AC circuit, so this panel is somewhat different as compared to the earlier. The sample and hold voltmeter is not kept here because it is not needed. And now here we can see instead of charging and discharging, there is one tab, that is the power on, because there is nothing like charging and discharging if the power supply is AC. And here is the frequency. So now we can change this frequency. I'm decreasing this frequency and keeping it somewhere around 10 hertz. 10 hertz frequency, AC voltage, and now the power is on. So I will push this button, and as soon the button is pushed, we can see that there is a graph is appeared. Here the green lines is showing the voltage across the capacitor, while the pink line is showing the voltage across the resistance. And there is a phase lag between the voltage across the resistance and the voltage across capacitor. Look at the pink line at the end and the green line at the end. To show it more clearly, I will reduce the frequency somewhere down to 2 hertz so we can see it more clearly. Now, as soon as I have kept the power button on, so we can see there are the two buttons. Now, when the frequency is decreased, we can see the voltage across the capacitor is very much high and the voltage across resistance is very much low. And at the same time, we can see that the peak of these two are differing by an angle of 90. So we can perform this experiment and take the observation with the help of this simulator. So at last, your friend Vijay Bharat from Sage University, Indore, India, again ask you to use this simulator and share your feedback. So please don't forget to download and use this simulator and provide me with your valuable feedback so that I can improvise my work. Thank you very much for watching the video, and if you like it, please subscribe to my channel. Thank you.